So we are gonna go through page 37, 38, maybe 39 together. I know we've been working these kind of on our own and struggling a little bit, so we're gonna work through these together, refresh what these were, make sure we understand how to solve things algebraically, how to solve things graphically, and go through kind of all the things. The reason we let you struggle for a day or two going through this is so that we go, oh yeah, I did 100% forget how to do that, and that's okay. We go through it so that we then remember how to do it. But if we let you struggle for a couple of days, we're a little less sassy when I go through something you did before. All right, so page 37 is where we are starting. I'll get a bunch of the code. So take a look at this. We've got two equations here. We're asked to find our system. We're going to solve it algebraically, meaning with numbers and calculations and adding and subtracting and stuff. Substitution or elimination. We did that kind of stuff yesterday. And we're going to solve it graphically. So we can start either way. Like, it genuinely does not matter if you want to start with graphing or if you want to start algebraically. It's not the prettiest of equations for graphing. Like, they're both in standard form. They're not very pretty. But we can do it. Looking at these two equations here, what method might we choose for solving it algebraically? Would we do substitution here or elimination, also called linear combination? What do you think? What you got, Amber? Elimination. Yeah, when we're in standard form, elimination's probably your better idea. What I mean by standard form is when I got x's and y's on the same side of the equal sign with coefficients and junk. Okay, so both of these have my x's and my y's and then an equal sign. So what we need to do for elimination, which I'm going to be doing my algebraically stuff here, I need to have at least one variable that when I add my two lines together is going to cancel out. So right now I don't have anything that works. Is there one equation or both equations that I can multiply to make them have the same number? Let's see, let's look at our smaller numbers. So let's look at this equation. Do you guys want to cancel out x's or do you want to cancel out y's? Sorry, I was looking straight down. Go ahead, Amber. Yeah. If I multiply this whole equation by 2, which I'm going to give us a wiggly line right here, and then I'm going to do it down here. So I'm multiplying everybody, whole thing. So we're going to have 4x plus 6y equals 18. We do that because then I can look here and see, all right, I got minus 4x and positive 4x. When I add these two lines together, my x's are going to cancel out. That's my goal. I want one of my letters to cancel out. And that's exactly what we do. We're going to add these two lines together. Old school, 3rd grade, big 3-digit number addition. We're adding in, no, I don't want to do that. Adding in columns like this, just below my squiggle line. So when I take negative 4x plus 4x, what do we get? 0 x's. Which I'm going to put it like that.
I found this on
Not you, nosy watch. Oh yeah, she is so nosy. All right, how about with my negative 6y plus 6y? 0y. How about negative 18 plus 18? 0. So I have 0 x's and 0 y's equals 0. What I have is 0 equals 0. Yeah, it looks like a face. Does anyone remember what that means? What would our solution be? No, it's not that there's no solution. You're close, though. We're headed in that same direction. Yeah, Amber. Yeah, infinite solutions. Because 0 equals 0. No matter what x is, no matter what y is, x could be 47 and y could be negative 3 million. 0, in fact, equals 0. That's a thing. So this is categorically, unbiasedly, and unexplainably true. What that means is we have an infinite number of solutions. Does anyone remember what that looks like on a graph? What does it look like on a graph if I have an infinite number of solutions, an infinite number of places where they cross? And if we don't remember, that's fine, because we're going to see it anyway in just a second, because we're going to graph the dang things. Oh, snap. So even just from algebraically, I can find out the information that I need. So then what we're going to do is we're going to graph these. And there's a few different ways you can go about graphing from standard form that are a little bit easier than switching it into slope-intercept form, which you can 100% do, 100% valid. You can also find your x and y intercepts. So if I look at this top guy, and I say, okay, when x is 0, I'm going to cover up my x. When x is 0, what would y need to be to make this true? 2 times 0 plus 3y equals 9. If x is 0, y is what? 3 times 0 equals 9? Does that work? If x is 0, let me write it down here. So 2 times 0 plus 3y equals 9. What's 2 times 0? 0. So then we have 3y equals 9. What does y equal? 3. So when x is 0, y is 3. That gives me a point for that top line. You can go the other way too. Not as pleasant on this one, but it's okay. So if y is 0, meaning this piece is canceled out here. If 2x equals 9, what does x equal? As a decimal. $4.5. So if I know that y was 0, because I physically blocked it out, this canceled out, we had 4.5. 4.5. Is that enough info to make a graph? Make a line? If it's a line, all you really have to have is 2 points. Make it chunkier. I have no idea how to make it chunkier. I'm gonna put another line. There we go. That's trying to be a chunky line so we can see stuff. There we go. That's better. Chunky line. So that's my top equation there. We're going to do the same thing for the bottom one. Or we can put it in slope-intercept form. Let's do that because that's good practice for us. So let's take this bottom guy and put him in slope-intercept form because that's something we're a little bit more familiar with, but it's still good for us to practice. If I have minus 4x minus 6y equals negative 18, what do I do to get this in slope-intercept form? I'm going to work this down here. I'm going to work this down here. What's that? Oh, yes. If you're going to do it the way we did before, I'm going to put this one into slope-intercept form, but that is 100% a valid strategy. How can I get this into our slope-intercept form, that y equals mx plus b? Because that's good for us to practice too.
Or we can do it that way, and we'll do the next one in a slope-intercept form. If we're in the mood to rock the standard form, let's do it. So let's go the other way. So y would be 3 is what I heard. So if x is 0, y is 3. What about if if y was 0? If we block out the y's, what do we get? Saying the longer we take to respond, the longer we do notes, y'all. Y'all have calculators on your desks. If y is 0, what is x? Negative 4x equals negative 18. What is x? 4.5. So we again wind up with an x of 4.5. And a y of 3. So what happened to my lines? They're on top of each other. When you have infinite solutions, when you wind up with the same exact equation, when you wind up with something inherently true, they are the same equation, the same line. Or it's duplicated. Or they're stacked on top of each other. Or, yo, they be matching. They're twinsies. So if you get something that is inherently true, that no matter what x is, no matter what y is, you get something true. It means we have an infinite number of solutions and we're graphing the same line twice, one on top of the other. I've got it up here in pink and in purple. They just stacked. Okay. We're going to skip E because, in all honesty, I have to look it up every single year because this is the only time we use these words. And why? I literally have to Google it every year because this is the only day of the entire year in all the classes I teach that I use these words. So we're going to not, just because, no. So just like cross out E. We're not doing E, skip E, whatever. Don't worry about that. We are not using them because they're the worst. So questions on this one, on our infinite number of solutions and what that looks like. I want to for sure do this one on 38. For sure Z's. And I want to start with I want to do substitution with this. So we're going to solve it algebraically. I want us to practice both that elimination, which is what we did in the last time, and our substitution on this one. So we are going to pick one of these equations. We're either going to do the pink one. Oh, that is not a pen. That was a line. We're either going to do the pink one or we're going to do the purple one. But we're going to make one of these be x equals or y equals. It genuinely doesn't matter. So which one do you want to work with? Pink or purple? It genuinely doesn't matter. You can use either one. Pink! What do we want to make it equal? X equals or y equals? Yeah, let's let it equal x because holy cow, do we have one step to get it to be x by itself. What can I do here to make x be by itself? Add the 2y. Plus 2y to both sides of the equal sign. And we're going to have that x equals 8 plus 2y. Sweet. The benefit of doing that is now that I know that x equals 8 plus 2y, I can go to my purple equation and substitute that back in. I know that x is 8 plus 2y. So we're going to replace x with that. So when we do that substitution, we're going to have our 3 times, but instead of x, we put what x is. 8 plus 2y minus 6y, that's a y, equals 6. And now I have only y's here. Let's go about solving this thing. I want to figure out what y is. So we're going to take our 3 here and do what with it? Distribute. So 3 times 8 gives us 24 plus 3 times 2y, 6y, minus 6y equals 6. When we simplify, what do we get in the next? What happens to my y's? They cancel. So we wind up with 24 equals 6. Does 24 equal 6? No. No. This is inherently false. No matter what x is, no matter what y is, 24 never equals 6. X could be 5 million. X could be $20,000. Like, x could be negative 400,542,000. It don't matter. 24 doesn't equal 6. So what does this mean about the lines? This system, what is our solution? There's no solution here. Does anyone remember what that's going to look like? I should put that in a different color. Let's find out. Let's graph these. And we can do this exactly the way we did before, where we were finding our x and y intercepts, because it's honestly a very easy method when we're in standard form. So, for the pink one, we're going to find our x-intercept, we're going to find our y-intercept. So when x is 0, so when x is 0, meaning this guy is 0, 0 minus 2y equals 8. What is y? It's not going to be 3. Negative 4. So if you need to do this, write it out. Totally fine. 0 minus 2y equals 8. Or negative 2y equals 8. So my y is negative 4. You can also solve these into slope-intercept form. That's 100% a valid strategy. This is just one of those things that's sometimes faster. We did slope-intercept form a bunch yesterday. I think everybody graphed from slope-intercept form yesterday. So let's do the other one where I say, what happens if y is 0? So if y is 0, this whole piece is 0, and what does x equal? 8. So I've got a point at 0, negative 4, and 8, 0. Oops. And 2 points is enough to give me a line. It's going to look kind of like that. Let's do the purple one. Same deal. I want to find my, that's not a pen, that was a line. I want to find when x is 0, I want to find when y is 0. I don't know what that item is. Oops. There we go. Okay. So if x is 0, this one, we have minus 6y equals 6. What does y equal? Negative 1. If we have that y is 0 right over here, let me make it so we can actually see the x. So now we're going to look, when y is 0, let's find our x-intercept. 3x equals 6. What does x equal? 2. Woo, that's not a pen. So here we've got our x and y intercepts. I have 0, negative 1. And I have 2, 0. Again, 2 points is enough to give me a line. They're a little close together, which makes it a little difficult, but be careful. And we'll be good to go. Because what do we see about these lines? They're parallel. Do parallel lines ever cross? No. They are parallel. That means there is no solution. So if we wind up with something that is inherently false, doesn't work, means we got parallel lines and there's no solution because they never, ever cross. Okay? One more of these and then we're done. Last one of these. You could 100% graph these the exact same way we've done before. You could absolutely put these in slope-intercept form, which is what I want to do for us here. And you could absolutely do these with substitution, or you can do these with elimination. It genuinely does not matter. In fact, I want you guys to do it. Work on it. Take some time, try this. I'm going to freeze my screen and I'll put it up here. I think I can do that. Let me try that. Okay. I want you guys to work on it and I'll show you what I do in a minute. I am going to do this with substitution and slope-intercept form. So if you want to do exactly the same as I do, just check your work with mine. I will do substitution, first one and the second one. And I will do graphing in slope-intercept form. So I'm going to write that up here. I want you guys to do it on your paper, and I will walk around as soon as I'm done writing. Okay? so backwards. There we go. Okay. I'm going to put mine up on the screen so you can see it. Looks like a lot of you are doing really good work. All right. So there we go. So that's all of my work. I put both of these guys in the slope-intercept form over here. For the top one, I added x. For the bottom one, I subtracted 3x. That gave me my slope-intercept. So for the pink line here, it's -2, and my slope was 1. Up 1 over 1, up 1 over 1. To give me my line. For my purple line here, we wound up with a y-intercept of +2 and a slope of -3. So it goes down 3, right 1. Down 3, right 1. Down 3, right 1. That gives me that intersection right there. I can see right there that they're going to cross. And since we did, since our intersection is really close to our y-intercepts, we probably actually wound up with a dot right on it. So it's really easy to tell from there that's going to be at 1, -1. But I still wanted to solve it algebraically, and I did substitution with my slope-intercept forms. I took the fact that I know that y equals x minus 2, and I know that y equals 3x minus 2, and I substituted this pink one in place of this purple y. That's what I did here. You could also have substituted it in over here, 100% valid, and that's totally fine. You should still wind up with x equals 1 when we simplify it down. Once we get down to an x equals 1, we know there is a solution, and to find a y value, we plug it into our equations again. So there's a lot of pieces to these. But we're going to continue working with systems for the rest of this chapter, all the way through about the end of the month.
And we are going to spend tomorrow focusing on choosing elimination versus substitution, how we pick and which ones we're picking. And we're going to practice with them more. But we're not going to do as much graphing tomorrow. In fact, we're not going to do any graphing tomorrow. Oh, snap. Okay, so we're just going to be focusing on the solving algebraically stuff. And tomorrow you will get the first homework of this chapter. Just as important. It's over solving. So if you want to look ahead at it, that's totally fine. That is topic 5, homework 1. But we're going to talk about it tomorrow more, and there's only 5 homeworks this chapter, and that includes the e-learning day, so you don't need to work at it. There's only 1 homework this week. All right, so our Unit 5 project's going to be on February the 24th. Told you it was going to be till about the end of this month. Snap. And yeah, that's kind of where we're stopping today. I don't want to do the other thing I had planned for you. So we're just going to stop right there. So use this time. I still have a surprising number of people with missing homework. Y'all, we've had like 4 homework assignments, y'all. And it's February. Look at that homework. It's easy points just sitting there waiting for you, because right now they're sitting at a 0. Anything is better than a 0. Homework makes up 20% of your grade. That means you are voluntarily choosing to get no better than a C in this course. That's assuming you ace every test. Okay? It's easy points, free points sitting there. Please take them. I want you guys to do well, but there's some things I can't change, like the weight of homework and tests.